Lesson 2 is on the formal definition of a function. So we've talked about like the concept of being a function and how basically when we're talking about functions, there's a relationship between two situations, two quantities, something going on. And those don't just apply to linear situations or those with a constant, throwing a ball or dropping something with gravity comes into play can also be considered functions. So we have our formal definition here. And I'm going to use a text box, and I'm just going to say it's a correspondence between one set of inputs and another set of outputs, such that each input corresponds to exactly, in capital letters, one output. Okay, and I'll kind of go through what it means. And it's going to be until we get into it, I know it's a little more difficult because we're really only familiar with functions. So it might be hard picturing what isn't a function, but we'll get there. Okay, so this correspondence or relationship between our inputs and our outputs, our x's and our y's. But every input we have in, every x value we put into our function, into that rule, remember it's a rule, we only get one thing out of it. Okay, let's look at some examples. Let d be the distance traveled in time, t. Okay, so we're not using necessarily x and y here, but remember, when we have a table like this is going to be, our x value. In this case, it's t for time. But these are our inputs. This is the stuff we input into an equation. And then our distance here, that's going to be d, and that's going to be our outputs. Okay? So use the equation d equals 16t to the second. Now, guys, this is something we already know how to do, but we're talking about it differently. We're using different vocabulary, so it seems a little more confusing. But basically, d is our distance here, right? Distance equals 16 times whatever the time is to the second power. So all we're going to do is we're going to input values in for t. We've done that, right? So this right here, I'm going to input 0.5 in for t. And so this is going to be 16 times, I'm putting it in parentheses, 0.5 to the second power. Okay, this right here is going to be 16 times, input a 1 in for t, 1 to the second power. And I'm just going to grab a calculator, I'm going to do that. Now, you do need to be careful, though, using a calculator. Remember, depending on the calculator you use, what comes first, multiplying or taking it to the second power, the exponent, right? The exponent comes first. So we need to go 0.5 to the second power first, then times it by 16. If you type it in all at once, most calculators should take care of it, but I would test what you're using because you should get 4. If I type in 1 to the second power, well, that's just 1. 1 times 16 is 16. Okay, and then I just keep doing that. I'm going to take this 1.5 and I'm going to plug it in here for t. Okay, and that's going to work out to be on my little cheat sheet here, 36. If I put 2 in for t, 16 times 2 to the second, well, it's 16 times 4. 2 to the second is 4. That's 64. 2.5 in here, that's 100. 3 in here. So if I plug in 3, I'd go 3 to the second power. 3 times 3, which is 9 times 16, and that's 144. And then 3.5 in there, I get 196. If I put 4 in there, that's 256. Okay. Now it says, are the distances calculated equal to the table from lesson 1? So in our last lesson, when we did the concept of a function, remember the stone or whatever falling. But when we started it out, remember we had, not these 0.5s in here, but we were multiplying by 16 each time, right? 16, 64, 144, and 256. So I'm just going to put yes, okay? If it doesn't make sense, go back and watch lesson 1 notes again. Does the function d equals 16t to the second accurately represent the distance the stone fell after a given time t? In other words, does the function described by this rule, remember function's a rule, assign t to the correct distance? So, okay, remember that stone, or I called it a bowling ball, was falling, right? So does it correctly describe it? And yeah, we're just going to say yes. Okay. And explain. I'm just going to say the time corresponds. Sorry, I should have done a text box again, to a correct and different distance. Okay, and that different part is important for being a function. Because remember, if we go back to our formal definition here, it's a correspondence, right, back and forth between two things, between one set and another, where each input it corresponds to exactly one output. Okay, so when I put in 1, I get out 16. I don't get out 16 and 132, right? We only get out 16. Okay, so that's why it's different distance, doesn't go to the same. Okay, so let's keep that in mind now when we're talking about functions and what does it mean to be a function? Each input has exactly one output. All right, so can this table represent a value of functions? Okay, pay attention, you might sit like this in your homework. All right, so I don't have a rule. Okay, there's a function up here, y equals something times x plus something, I don't know. Okay, there's something up here. Okay, we don't know what it looks like. But there's a rule that gives us this table, that when I input a 1, I get out a 7. Okay, so when I drop 1 in, I get out a 7, like I did here. When I inputted 0.5 in, you get out 4. When I input 1 in, I get out 16. Okay, we just don't have this for this equation. Okay, so when I input a 3, I get out a 16. If I input a 5, I get out a 19. Or if I input a 5, I get out a 20. Do you see, like right here? If we're inputting 5, we're getting 2 different values out. Our formal definition says each input has exactly one output. So what does 5 go to? Okay, does it go to 19 or go to 20? So in this case, can this table shown below represent values of a function? We say no. There's nothing wrong with the values. Could be real life data or something, okay? But it can't be a function. And we're going to just say the input 5 has 2 outputs, not a function. Okay? All right, so again, just identifying functions right now. All right, so number 3 here, there's a rule hanging above here where we input 0.5 and we get out a 1. Okay? We input 7, we get out a 15. If I input 7, I get out a 10. Well, which is it, right? Okay? When we input a 7, we can't get out 2 different values. Always think of a calculator. You type things into a calculator, it doesn't give you 2 answers. So is this a function? Again, no. The input 7 has 2 outputs. All right, so looking at another one, similar. Can the table show below represent a function, a value of functions? Explain. Okay, well, let's go at it. If I input a 10, I get out a 32. If I input out a 20, I get out a 32. Is that okay? If I input, can the 2 different inputs go to different, or 2 of the same output? The answer in that one is yes. Now I'm going to look here quick just to be sure that there are no inputs. But we're really saying, remember the definition says every input has exactly one output. It doesn't say that outputs can't have more than one input. I know, that gets a little tricky. So you always want to think of it as we're going from inputs, I'm inputting something, I only can get one thing out. So if they have the same output, that's okay. I inputted a 10, it gave me 32. I inputted a 20 into my function, it gave me 32. They can be the same thing, but I can't input the same number and get different answers, right? So this one is yes. Excuse me. And we're just going to say each input has exactly, so again, we're talking about the inputs here, one output. Okay, each input has exactly one output. That's okay. So when identifying functions, just really focus on the inputs, okay? One input can't get 2 different outputs, okay? Because of the definition of function says each input corresponds to exactly one output.